Okay, everybody, welcome to the notes on solving quadratic systems. Okay, solving quadratic systems. It's chapter 4, section 9. So very similar to what we did in 3.1 and 3.2, except for now we're going to have systems of linear and quadratic equations and just quadratics. All right. So here we go. Some things to know. If we have a linear quadratic system, what that means is that you can probably tell by looking at the pictures, we have a line and we have a quadratic. Okay. If we have a line and a quadratic where the line intersects it twice, we're going to have two solutions. If we have a line and a quadratic where the line is actually at the max or min of the quadratic, then we're going to have one solution. And if they never intersect, we're going to have no solution. All right? So far, just three options. Okay, three options. We can have two, one, or none. All right. Now, how to solve one? Okay, so here we go. Solving a linear quadratic system by graphing. Graphing should be the easiest way to do it. We get them both equal to y. We put it in our calculator, and we're going to use our calculator to get some solutions. If you had graph paper and you know how to graph it, it might be faster just to do that. And then we're just looking for where the intersections are. No problem. Okay, so let's take a look at this problem right here. Got it, number one. Either on your calculator or on graph paper if you have it, see if you can graph those two, this quadratic equation and this linear equation, and get a solution. Pause the video now and go ahead and graph that. All right, so we're back. Hopefully you have graphed these, and hopefully you got, for your answers, -3, 0, and -2, 1. Okay? If you didn't, try again, either on your calculator or by hand, see what you get. And if you still need help with those, let me know and we will go over those in class. All right. Problem 2 down here. Solving a linear quadratic equation using substitution. So what we're able to do is a couple things. First, substitute x plus 3 for y in the quadratic equation. So if we know y is equal to this, we can substitute it in right there. Then we have x plus 3 equals that. The next thing we're going to do is we have this now. We're going to see if we can factor that. We factor that and solve for x. Okay, we solve for x and we get x equals 1 and x equals -3. Then we're going to take 1, plug it in, substitute x into the easier equation, so that would be the linear one. Plug x in for both choices for x, and that gives us our corresponding points, and that's the solution. Okay, so I'm going to walk you through this one a little bit, since graphing is probably a little bit easier for us, and factoring sometimes gives us some trouble. So let's walk through this one together. So first thing we're going to do is substitute in. So I have x plus 5 equals -x squared minus 3x plus 10. Okay? Now, step 2. I'm going to set it equal to 0. Okay? So I have, I can't stand negative quadratics for me, so I'm going to change that just so we know. If you don't care, then you don't care. But factoring a negative is a pain in the butt. So I'm going to add x squared to this side. Okay? I'm going to add 3x to this side, and I'm going to subtract 10 from this side, and that equals 0. Then I'm going to see, can I factor that? I know that there's only one way to get negative, or two ways to get -5 with a product. So it's -5 times 1 or 5 times -1. Since this is a positive, I'm going to make the 5 positive and the 1 negative, so that's -1. That's 5x, -x, that adds to 4x. So x equals -5 and x equals 1. Okay, so the next step, I'm going to plug that back into this. Okay, so if x is -5, y equals 0. If x is 1, y equals 6. So, big finish time. My answers are -5, 0, and 1, 6. And those are my answers. Seems easy enough. Let's take a look at the next page. We can also solve quadratic systems using the same methods you used for linear quadratics. So we can use substitution. Okay, so we can substitute this one here for y. When we do that, we get this right here. We factor, and then x is either 0 or -4. We substitute those values in, and we get our answers. We can graph the equations. So if we graph them, we can find where they intersect. Okay, So there's all these, every single, the ways that we learned still work. What I'd like for you to do is see if you can get some answers to A and B here using either substitution or graphing. See if you can get some answers there. Go ahead and pause the video now, get some answers, and then I'll give you the correct ones. Go ahead and pause the video. All right, so you've unpaused. Hopefully for the first one, for your answers, you got 0, 5, and you got 2, 1. All right. Hopefully for part B, you got no solution. If you didn't get those, try them again. Check them in your calculator. See if you can get what I have. And if you didn't, let me know, and we will go over those in class. Okay. You can use techniques for solving linear systems of inequalities to solve a quadratic system of inequalities. So, when we had linear systems of inequalities, we graph them, and where they overlap is the solution. Okay. Same thing for quadratics. Okay. So, what is the solution? First, we graph the first one, then we graph the second one, and we just identify where the overlap is, and that region is our answer. The solution of this system is the region where the graphs overlap. The region contains no boundary points. Okay. So it's just this area. It's where they overlap. All right. Let's take a look at 4a. What is the solution of this system of inequalities? Okay. What is the solution of this system of inequalities? So we'd have to graph both those. So let's do that. Let's go ahead and pause the video here. You can practice graphing some inequalities or graphing some quadratics, and then we'll look at them. Go ahead and pause the video now. All right. So what I've done is I've graphed this one in green and this one in purple. You'll notice that this one has a dashed line because here, I'll add in some more dashes so you can make sure we see that, because it's greater than and this is less than or equal to, so that one's solid. Let's do the shading. I wanted to do the shading together. So let's shade the green one first. It says that it's less than or equal to, so this is going to be shaded everywhere underneath. Okay, it's less than, so it's shaded everywhere underneath. Okay, so that's where all this shading goes, and it would go down forever, right? It would just keep going, okay, all the way down there. My parabola went further. All right, the shading for the purple one is greater than, so it's above it. It's all of this. Okay, and the answer is just this part right here that overlaps. This is my answer. Okay, that's the solution. And that's it. That's all we got to do. Part 4b says, how many solutions can a system of inequalities have? Okay, how many solutions can a system of inequalities have? So think about that for a second. Like, could it have, is it going to be one, or is it going to be none? And the answer is actually, it's all sorts of things. It could be infinitely many solutions. Okay, it could be, if they both go in the same direction and they overlap some, it could be infinitely many. Okay. If they didn't overlap at all, it would be none. If they only overlapped at a single point, it would be 1. So the answer there for the reasoning part, you know, it depends. It could be infinitely many, none, or 1. All right. Okay, that's it for the notes. All we had to do was those couple problems. Hopefully you didn't find this too complicated, and we will go over any questions that you have when you get to class tomorrow. All right, see you next time. Bye.